Welcome back, everyone. Today we're going to be talking about squaring binomials. Just as a quick reminder, binomials have two terms. Those terms are separated either by addition or subtraction. They can be comprised of numbers and variables. And when you're talking about the variables, they have to have positive integer exponents only. So no fractional exponents, no negative exponents, only positive integer exponents are allowed with the variables. So just that's a quick refresher, and now we can move into squaring them. So when we talk about squaring binomials, we're not just we can't act as we've normally done before and distribute the the squaring the exponent of 2 inside, because it's separated by addition or subtraction. The terms are separated by addition or subtraction. When they're connected by multiplication, as in the case of a monomial, when we were talking about applying exponents to monomials, you just distribute, you multiply that exponent inside, but we can't do that here because they're separated by addition and subtraction. So we have to apply a different method. And it's the same thing as we were doing before when we were talking about multiplying binomials in the last section. So when we're talking about squaring, when you see something with squaring a binomial, we have the quantity 4 plus t squared is equal to 16 plus 8t squared plus t to the 4th. True or false? Okay, so in order to evaluate that, we're going to apply the FOIL method, because when we see that this quantity 4 plus t squared is being squared, what that really says is that we're multiplying it to itself. So we're going to have 4 plus t squared times 4 plus t squared. And then we apply the FOIL method, first, outer, inner, last. So the first is going to be the 4s. It's going to be 4 times 4. So we're going to have 16. And then the outer is going to be 4 times t squared. So we're going to have plus 4t squared. The inner is t squared times 4. So again, we're going to have plus 4t squared. And then the last is t squared times t squared. So remember, when we multiply monomials together, you add the exponents if they're the same, if it's multiplying 2 of the same variable. In this case, we're multiplying t's together, and we have t squared times t squared. So we're going to have plus t to the 4th. The only thing we can do now is potentially combine like terms, which we can combine 4t squared plus 4t squared to give us a final answer of 16 plus 8t squared plus t to the 4th. So this is true. We evaluated ourselves. We saw that it was true. Okay, moving right along, we have to now just evaluate the next ones. Okay, so now we have 1/4 p plus 1/4 q quantity squared. So once again, we're talking about quantity, the quantity being squared, or this whole expression, this whole binomial. So what we're really saying again is 1/4 p plus 1/4 q times 1/4 p plus 1/4 q. We're just multiplying it by itself. Okay, so FOIL method, once again, first, outer, inner, last. First is 1/4 p times 1/4 p. So that's 1/16 p squared. Then outer, we have 1/4 p times 1/4 q. Well, 1/4 times 1/4 is 1/16. Can't combine the p and q, they're just multiplied together. So we have plus 1/16 pq. And it doesn't matter what order you write the variables in, it's just kind of standard notation to write them in alphabetical order. So that's why I wrote pq. But it doesn't matter because the order of multiplication doesn't matter, just to note. And then inner, we have 1/4 p, or I'm sorry, 1/4 q times 1/4 p. We can again multiply the 1/4 together. So that's plus 1/16. And then we have q times p times q, same thing. So I'm going to just write them in alphabetical order, pq. And now last, we have 1/4 q times 1/4 q. So that's plus 1/16 q squared. And now the only other thing we can do is combine these middle terms because we have a PQ and a PQ here. 1/16 plus 1/16 is 2/16 or 1/8. So we have 1/16 P squared plus 1/8 PQ plus 1/16 Q squared as our final answer. And I'm just gonna draw a line to separate that so I don't interfere in the next one. Okay, so the next one, we have another binomial. The only difference here is that the term is separated, or the terms are separated by subtraction instead of addition, but it's going to be the same idea. We're squaring this entire 1/3 minus m, the entire expression. So we have to evaluate 1/3 minus m multiplied by itself since it's being squared. 1/3 minus m. Same thing, first, outer, inner, last. First, 1/3 times 1/3, that would be 1/9. If you just multiply the fractions across like that, we have 1/9. Now, outer, we have 1/3 times m, but the m is being subtracted, so be careful here. So we'd have plus 1/3 times negative m, or minus 1/3 m if you just want to skip the middle step, but it can be helpful to account for the negatives this way just so you don't miss them. The inner, it would be negative m times 1/3, so we have plus 1/3 negative m. And then last is negative m times negative m. Okay, so 1/9 can stay. We then now have minus 1/3 m, minus 1/3 m, and then negative m times negative m is a positive m squared. The only other thing that we could do to simplify this a little bit is combine the middle terms, because we have an m and an m here. So we can combine them, combine like terms. So we have 1/9 minus 1/3 m minus another 1/3 m. That'd be negative 2/3 m. So we have minus 2/3 m plus m squared. And that would be our final answer. We can't simplify anymore. Excuse me. Okay. For our fourth and final question, we're evaluating. This one isn't necessarily squaring binomial, but something special is going to happen here. So I will explain that as we go. We have the quantity 5x minus 2y times the quantity 5x plus 2y. Now, if you notice, these things would be called conjugates of each other, because in one case you're subtracting the second term, and in the other one you're adding the second term, so they're each other's conjugate. So when you see conjugates happen, something special or something noteworthy happens here. So let's multiply and see what happens. Okay, so we're going to apply the FOIL method again. That's just kind of custom, or not custom. That's customary when you are evaluating, or when you're multiplying two binomials, because that way you account for all of the multiplication that happens. So first we have 5x times 5x. So our first term is going to be 25x squared. Outer, we're going to have 5x times positive 2y. So we have plus 10xy. And in the middle, we have negative 2y times positive 5x. So that would give us minus 10 or negative 10 xy. And then our last terms are 5x. I'm sorry. Nope, our last terms should be, let me erase that. I messed that one up for a sec. Nope, that's not what I want. Oh my goodness. Our last terms are going to be negative. Okay, my computer does not like me apparently right now. Should be a pen, not a highlighter. And gotta erase one more time. My apologies for the delay here. Okay, so finally we have negative 2y times positive 2y, which would give us a minus 4y squared. Okay, so if you notice here, the two terms from the outer and inner multiplication, or the middle terms here, we have positive 10xy and negative 10xy. So these are going to cancel each other out. And when you're multiplying conjugates together, which is, again, the same expression except one has addition, one has subtraction, the middle terms will cancel out. Like, that's what's special about multiplying these conjugate binomials together, is that one will cancel out, or the middle terms will cancel out, and all you'll be left with is the squares of the outer two terms. So we're going to have 25x squared minus 4y squared, and it results in a difference of squares. That's where that comes from. And if you were to factor this back out, you'd end up with these conjugate terms, where there's no middle term. It's just the difference of squares. All right, and that would be the end of this this video. Thanks for watching, and I will talk to you next time.